Welcome to the DIY Honda Garage channel. DTC P0335 indicates a CKP Sensor No Signal issue, which pertains to the crankshaft position, CKP, sensor's failure to transmit necessary signals to the powertrain control module, PCM, in your Honda Civic. This diagnostic trouble code arises when the PCM detects an absence of signals from the CKP sensor, which is crucial for engine timing and performance. Located typically at the front of the engine, the CKP sensor plays a vital role in determining the position of the crankshaft and consequently helps in managing ignition timing and fuel injection. When this sensor fails or does not provide signals to the PCM, it can lead to erratic engine behavior, impacting overall vehicle operation. Your first course of action should be to verify the existence of the DTC via diagnostics before proceeding with further troubleshooting steps outlined in the service manual. The CKP sensor plays a central role in monitoring the crankshaft's position, thereby assisting the PCM in controlling various engine functions like ignition timing and fuel injection effectively. This sensor is typically located at the front of the engine block or near the crankshaft, allowing it to accurately gauge the crankshaft's rotational position. The information transmitted by the CKP sensor is indispensable for maintaining optimal engine performance. Without this data, the PCM cannot adjust engine parameters properly. The PCM is essentially the brain of the vehicle's engine management system and relies heavily on input from the CKP sensor to ensure smooth operation. When this signal is lost, it can lead to performance issues, stalling, or failure to start. Understanding the function and position of these components is critical to diagnosing the issue. Several factors can lead to DTC P0335. A primary cause of this code is a failure of the CKP sensor itself, which can occur due to wear or internal electrical failures. Additionally, damaged or frayed wiring can disrupt the signals transmitted from the CKP sensor to the PCM, causing this error to be logged. Poor connections, such as loose terminals or corroded connectors at the CKP sensor or PCM, can also prevent proper signal transmission. In some cases, the issue could trace back to a malfunctioning PCM that fails to recognize the signals received from the sensor. Each of these potential causes requires careful inspection to determine the source of the problem accurately. The symptoms associated with DTC P0335 can significantly impact the drivability of your Honda Civic. One of the most immediate indicators is that the engine may not start at all due to the PCM failing to receive the crankshaft position signals necessary for ignition. If the engine does start, it may stall unexpectedly while driving, leading to an unsafe situation. Drivers may also notice poor acceleration as the engine struggles to maintain performance without accurate data from the CKP sensor. Moreover, the check engine light will illuminate on the dashboard, providing a clear indication that a diagnostic trouble code has been logged. Recognizing these symptoms early is key to preventing further damage to the engine or other components. In the first troubleshooting step, you will need to turn the vehicle to the on mode to initiate the diagnostic process. Once in this mode, use the Honda Diagnostic System HDS to clear any existing diagnostic trouble codes. This step ensures you are working with the latest data and eliminates any previous errors that may not indicate a current problem. After clearing the DTC, start the engine as you check for both pending and confirmed DTCs via the HDS again. If DTC P0335 reappears during this check, it confirms the presence of a fault that needs to be addressed. If no DTC is indicated, this may suggest an intermittent fault, highlighting the need to examine connections and terminals at the CKP sensor and PCM closely. In this step, Ensure the vehicle is turned off to safely handle electrical components. Disconnect the CKP Sensor 3P connector to isolate the sensor from the circuit. Once disconnected, turn the vehicle back to the on mode and proceed to measure the voltage between two critical test points. Test point 1 is the CKP sensor connector number 3, while test point 2 is the body ground. This measurement will help you determine if the VCC1 wire is functioning correctly. You should see about 5.0 volts. If so, you can ascertain that the VCC1 wire is intact, and you can move on to the next troubleshooting step. However, if the voltage is not at the expected level, you will need to investigate further into potential wiring issues. This step focuses on checking the continuity of the VCC1 wire. Begin by turning the vehicle off again for safety. Use the HDS to short the SCS line and wait for over a minute to ensure all systems are reset properly. After that, disconnect the PCM connector E80P to work on the circuit integrity. Using a multimeter, check for continuity between test points. Test point 1 is the CKP Sensor 3P connector number 3, while test point 2 is PCM connector E80P number 70. A continuity check will tell you if the VCC1 wire is functioning. If there is continuity, the VCC1 wire is verified as operational. If there is no continuity, it indicates an open circuit that must be repaired between the PCM and CKP sensor. In step 4, the focus shifts to determining potential failures along the CRKP line. First, you will once again measure voltage, this time between test points connected to CKP sensor connector number 1 and a solid ground while the vehicle is in the on mode. Make sure the CKP Sensor 3P connector remains disconnected during this assessment. You should be looking for a reading of about 5.0 volts. If this threshold is met, it suggests that the system wiring is intact, allowing you to progress to the next troubleshooting step. Conversely, if the voltage measures lower than expected, then further investigation is required into potential wiring issues or failures within the CKP sensor itself. Next, in troubleshooting step 5, you'll be measuring the voltage between test points again, this time focusing on verifying the SG1 wire functionality. Ensure the vehicle is still in on mode with the CKP Sensor 3P connector remaining disconnected. You will measure from CKP sensor connector number 2 to connector number 3. A reading of approximately 5.0 volts confirms that the SG1 wire is operating correctly. If the reading indicates the wire has the appropriate voltage, you should replace the CKP sensor, which may be faulty. If the voltage is not observed, you will need to check for continuity as described in the next step, which will guide you through identifying potential wiring issues. For troubleshooting step 6, your task is to inspect the SG1 wire more closely by checking for continuity. First, turn the vehicle to the off mode for safety, and then short the SCS line with the HDS, allowing for the reset of the system. This is a critical step to ensure the diagnostic tool can communicate effectively. Disconnect the PCM connector E80P, isolating it from the circuit, and measure the continuity between CKP sensor connector No. 2 and PCM connector E80P number 71. Continuity here confirms that the SG1 wire is intact. If continuity does exist, check service information for further troubleshooting steps, or substitute our known good PCM and recheck if the DTC resolves after replacement. If not, the next step will require you to address any open issues with the SG1 wiring. In the 7th troubleshooting step, focus shifts towards checking for a short in the CRKP line. Again, turn the vehicle to the off mode to ensure no power surges while handling wiring. After power is off, proceed to jump the SCS line with the HDS, allowing the system to reset for a minute. Disconnect the PCM connector E, 80P, and check for continuity from PCM connector E, 80P, number 44, to ground. If you find continuity, it indicates a short in the CKP wire that needs to be repaired, which is crucial for the CKP sensor's proper function. If you do not see continuity at this point, it means that the CKP wire is not shorted, prompting you to move on to the next step. The final troubleshooting step revolves around checking for an open circuit within the CKP line. This entails measuring continuity between CKP sensor connector number 1 and PCM connector E, 80P, number 44, while the vehicle remains in off mode. Ensure that the CKP sensor 3P connector is disconnected during this assessment. If continuity is present, it confirms that the CKP wire is functioning properly. In this event, check any authorized service information related to the symptoms you are troubleshooting. If continuity isn't established, you will need to repair any open in the CKP wire between the PCM and CKP sensor, which is crucial for restoring the correct signal to the PCM. After completing all necessary repairs and replacements, it's vital to perform a final verification to ensure that the system is functioning correctly. Begin by retesting for any Diagnostic Trouble Codes, DTCs, using the Honda Diagnostic System, HDS. The goal here is to confirm that DTC P0335 does not reappear, indicating successful resolution of the issue. Besides clearing the codes, check that the Powertrain Control Module, PCM, is receiving accurate signals from the CKP sensor. The PCM should respond correctly to the signals it is tasked with monitoring. If everything checks out, you can be confident that the repairs were effective. Preventive maintenance is a crucial aspect of vehicle upkeep, especially for components like the CKP sensor that influence engine performance significantly. Regularly inspecting electrical connections and wiring for any signs of wear, corrosion, or damage can help prevent issues related to DTC P0335 from arising in the first place. Additionally, ensuring that the CKP sensor functions as intended is vital. Consider routine testing as part of your maintenance schedule. If any irregularities arise, addressing them promptly will go a long way in maintaining vehicle reliability. Developing a habit of regular diagnostic checks can save time, money, and prevent future headaches. In conclusion, understanding the role of the CKP sensor is integral to addressing issues related to DTC P0335 effectively. Proper diagnostics using the HDS will assist in identifying faults accurately and ensuring timely repairs. It's also essential to be aware of the symptoms linked with this DTC, as early detection can prevent more complex issues later down the line. Regular maintenance and inspection can help in safeguarding against wiring issues and sensor failures. By being proactive and informed, Honda Civic owners can ensure a longer lifespan for their vehicles, while avoiding unnecessary repair costs. Please like and subscribe to the channel. See you next time.